Hello. So good morning. Thank you very much for coming to this session on Spot the Difference Automated Visual Regression Testing. My name is Viv Richards and I'm a QA consultant in Wales. So in this session we're going to be looking at why often manual testing isn't enough. We're going to be looking at firstly some common problems with end-to-end UI testing, primarily with Selenium. Some ways to overcome some of the common issues you may find if you're familiar with it. And then we're going to be looking at visual testing. So we're going to look at what it is, how we can perhaps help replace some of your UI tests. And when people often look at visual testing, they get to a certain point and then they think it's too much trouble and they just leave it alone. But in this session we're going to be looking at some common problems and ways to overcome them. There's a link on this board. I will share it again at the end. And there's a NuGet package. So if you want to try and see if it's for you, it's very rough and ready. It's C#.net, but the things I will show you can apply to any sort of visual testing framework. So why do we bother automating end-to-end tests in the first place? Well, it can be more reliable. Of course, it depends on the person writing the tests or the checks. But because it's performed by tools and scripts, there's less distractions, and also then they can be executed a lot quicker because it's just running through the checks that we tell it to. But there are probably a lot more common issues than this, but these are just a few that I've encountered. So the first one is investments required. And this isn't just to be able to purchase a tool or framework off the shelf. It's getting people on board with this new tool or framework that you're trying to integrate. So in teams I've worked on, they've been primarily manual testers. So what we've then been doing is trying to get developers to work with testers to try and build a framework to help them move and transition from just manual testing, identifying the value in the checks and automating them. And it's only a practical option as well when you're running the test cases over and over again. If you're just running them once or twice, you're probably not going to want to invest time in trying to automate these checks. But the most important thing, especially for this talk, is that automated testing, it doesn't entail human observation. So a lot of the time you may find that you can say that something exists somewhere, but you can't say if it exists exactly where you expect or whether or not it looks how you expect it to. And it can be a slippery slope. So I've seen this a lot whereby companies have tried to get end-to-end UI tests, and basically people get a tool or framework, and just because they can do something, and I've seen this both in the test and developers sort of landscapes, people just want to do everything just because they can, because they've got this new tool that seems to do everything. And just because you can do something, it doesn't always mean that you should. So I'm not sure how many people are familiar with this. So this is the inverted testing pyramid. So this is the ice cream cone anti-pattern, and it's adaptation of Alistair Scott's ice cream pyramid. So the idea is, for those that don't know, is the lower down the pyramid you are, the tests tend to be quicker to run and execute. Higher up, the slower. And then likewise, the lower down, the cheaper the checks are to implement and maintain. And then higher up you go, they become more expensive. And at the top, you're always going to have this manual exploratory testing bubble. There's always going to be a big investment in wanting to do exploratory testing and manual checking. And you should be doing exploratory testing through all the levels anyway, but primarily you get a lot of sort of manual exploratory testing at the end. So I've seen teams whereby they have a lot of UI checks. And the reason being, from people I've spoken to, is that they've identified there's not many unit or integration tests. So they're just trying to catch all. So they're creating all these UI tests to try and do, in my opinion, too much. These tests are difficult to implement and maintain. They're doing too much. They're going through all the levels just to try and get a result. And it takes time to try and get a meaningful result back. I've also seen this whereby similar teams have identified that they've got too many UI tests. So what they do is they start to push the test further down the stack. So they start then to create unit tests. And they do this with things like test-driven development. Or one of the things I really like about this is where you see you have lots of UI tests. So the teams then try to create lots of unit tests, but they actually pair up. So we use whip limits. in the previous companies I've worked in. So these are work in progress limits. So when you work as part of an agile team and you commit to delivering, say, 5 stories as part of a sprint, to ensure there's constant flow through the sprints, what you do is you say, well, I only want to pick up, the team to pick up 3 of these stories, so you can only have 3 in flight at one time. And what that encourages teams to do then is to pair up on tasks to get constant flow, to get work over the line. And lots of people that I've spoken to, testers and developers, they don't see how they can add value by pairing together. From my experience, testers tend to have the best domain knowledge of the business, and developers have the expertise, the skills to actually implement the checks. And together, I've seen really positive results whereby testers and developers have been able to identify really valuable checks and unit tests at a lower level. But the problem with this is, even though it's great that there's lots of unit tests, sorry, it's great that there's lots of unit tests, there aren't integration tests. So even if you had thousands and thousands of unit tests, if you don't have integration tests, then what good is that? How do you know that they play nicely together? And it's something I like to call fragile testing. So when you're trying to deliver software really fast and you're working within 1 or 2 week sprints and you're trying to ship products, if you have tests that take too long because you're relying at the UI level on these checks, the feedback loop just isn't quick enough and it's not allowing you to adapt. You need these checks to be giving you quicker feedback so then you can react to them. So then you've got more confidence in the software that you're trying to ship. So this is perhaps what you're a bit more familiar with. This is the testing pyramid, and it's quite controversial in the testing sort of world, but I quite like it because it illustrates whereby, from my experience, I've seen companies with lots of UI tests, and it just sort of illustrates that you should be thinking further down the stack, trying to get more unit integration service tests. For example, if you had an integration test to see if an API was up at this level, then you could fail faster than trying to do something on the front end, realizing that the service wasn't running and then failing. So it's about identifying the value further down the stack and failing as quickly as possible so you can adapt to change. So why not just stick to manual testing then? Because the thing that allows us to do, is we can actually see when things go wrong. And currently, through lots of solutions, UI testing with Selenium, you don't get that. Again, these are just a few examples, but it can be time intensive. If you work as part of a Scrum team or in an Agile team, when you're doing sort of sprints, you have ceremonies and stand-ups, planning, refinement. There's something all the time, so there's constant distractions. So it's difficult to try and stay in the flow and get things done. And this leads on to human error. Again, constant distractions, and it does take up human resources. So while you're trying to do the manual testing, you could have automated checks where there's value in them running in the background to save you some time. And again, it's only practical when test cases are run once or twice. So when I've seen teams trying to get onto automation and writing automated tests, it's difficult because even when you give them the wheels for the cart, because they're in these 2-week cycles, they just never have time to try and stop to put the wheels on because they're constantly trying to ship software. And the problem with that is they never automate because they don't have time, but they never have time because they don't automate. And it's about trying to break that cycle and identifying what checks add the most value and working smarter within our teams to try and identify the value and automate the right things for the right reasons. And it can be quite daunting as well. So when you're moving into trying to get into automated checking for the UI level, there's just so many options. These are just a few. And it really depends on so many different things, like the operating system that you're using, the language. So if you're trying to create an automated UI testing framework, you're probably, if your testers aren't that familiar with writing code, you're going to want to try and stay in a language that's familiar to the developers at least, so they can try and get the support. It depends on browser support as well. Some of these just target, for example, IE, other ones like Slendroid, obviously Android. Appium is quite an interesting one. So this allows you to, if you use Selenium and you write your automated UI checks, you can actually use Appium to then change the device type and run your checks against an Android or iOS device. So it allows you to extend the Selenium sort of driver support. So it's really nice. Some of these, like Visual Studio Coded UI, give you a nice GUI, whereas other ones, they rely on you writing code. So it really depends. There's so many different options. It depends on the skill set and your requirements. It's not a one-size-fits-all. And again, the investment in trying to get on board with one of these tools, not all of them are well documented or have a big community of support. So it really depends on how much support you're going to get from your teams a lot of the time. So a lot of the teams, again, I've worked with, they pick Selenium. And the reason for this is because it's open source. You can dig into the code. You can see what's happening. The one problem with this, though, is that I've seen is that when teams who have primarily manual testers try to get them on board with Selenium, they get carried away in writing sort of helpers within the framework. And the problem is, while that's quite a nice idea because you no longer have to do driver.findElement by ID or CSS selector and then do like a click or an action, they will just wrap all of that in a helper. But then as soon as that helper stops working, you lose the lack of support from the community. And if one or two people who leave the framework, like I've seen before happen, all of a sudden the testers are just stuck because the people they rely on who wrote those helpers, they don't have the support. So it's about keeping it simple as well. Selenium, it has a massive sort of language support. These are just a few of them. For the companies I've worked with, they primarily use .NET. And again, like I mentioned with Appium, the browser support out of the box is very good, but you can extend it as well. But it's not a silver bullet. Again, I just want to reiterate, just because you can do something with it, you shouldn't always, and it's about identifying, what adds value to you and your application that you're automating. There's lots of browser compatibility issues. So we had to support IE, Firefox and Chrome. And the problem is that the speed in which you execute the tests, they differ slightly. And they also render differently. So whilst when you do normal UI testing, that doesn't really matter. When you come to look at visual testing, the way that the browsers render the content, it really does matter in this case. And the execution speed. So I've seen probably one application being tested at the UI level taking 15 minutes to give you all the passes or failures. And then when that one test suite is put with the other 45 that this company had, it took over 4 hours. So come the end of the sprint, when they wanted to know whether or not they could ship the software, none of the manual testers could touch the software because they had to run these tests that took 4 hours before they were prepared to let the testers actually get in and test the software. And it's just too long to try and give them some level of confidence whether or not to ship the software. And maintainability. So when you start trying to support lots of different browsers, you'll recognize that if anybody has written any Selenium tests before, you have to start adding weights and things like this into your code because the speed in which the browsers render, sometimes it's too quick. So you have to tell it to slow down to take account for different driver types. And the way that you interact with elements as well. So some may allow you to find an element and do a .click. Others may want you to find an element and do a send keys enter. So you have to take account for all these different things. And all of a sudden, the tests that you're writing become quite difficult to maintain, and the code base grows quite large just for some simple tests. So I wanted to ask, so apart from sort of maybe localization testing, where you're checking some text, how valuable are these checks? So what we've got here is a dummy form, and we're just checking, it's C# and Selenium, we're finding some text using these selectors, I'm just checking if they exist. So at a company I previously worked for, they had a call one Friday evening, and basically what had happened, the customer was unable to progress through the application, and it was quite critical for them. So they called up the support desk and they asked, can you tell us what's wrong with this page? Why can't we proceed? The support person then went to the DevOps team. They checked the CI logs. They could see all the tests had passed, and they couldn't work out what had happened. They went onto the application. They could see there was no button, or they couldn't see the button. But all wasn't as it seemed. So there'd been a CSS breaking change, or something had been styled, and the tests were still passing because the element was still present. So Selenium could find within the DOM, or the document object model, it could find the element. So the tests were right. But the problem is it couldn't actually tell you where the element was. So it was useless to the end user. And just very quickly before we go on, I just wanted to cover a few things. So Martin Fowler explains this a lot better than I ever could. But if you find that visual testing isn't for you, but your tests are becoming quite difficult to maintain, page object patterns are a really nice thing for your Selenium tests. So, for example, when you start to interact with various elements, if you find that you're interacting with the same element many times, you can extract that out into an object, and then you declare there how you interact with that element. So if an ID or a class name changes, you just change it in the object level, and all the tests then inherit, the interaction to that object. So everything it'll be easier to maintain because you've only got one place to declare this thing rather than in many tests. And QA selectors. So I've heard these called data selectors. I've worked on applications whereby the ID for some strange reason has always been generated, and the class names, for some reason, the developers and testers don't work together that well, and so they'll just develop the front end. The tester then will say, well, how am I supposed to find this element? This element shares the same class name as another element, and then they go down the dirty path of just XPath. So what you can do is, so the top is markup for this form, or very rough, but what you can do is, within the class, so you wouldn't litter these throughout your application, but just for the happy path of your application, if we take the cancel button, for the class, you give it a QA hyphen, the element type, which is button, hyphen, and then the name. So all of a sudden, what this allows you to do is, when front-end developers are making changes, they can see there's a QA selector, so they're less likely to make breaking changes. And if you've got people who are trying to transition into writing Selenium code, they don't have to think, am I using an ID, am I using a class, am I using XPath? They know that they can just look for the class name that's already there or should have been added. So it helps for maintainability and to stop breaking changes, and in my experience this has worked really well. Other people put them in the data tags, which is another option as well. So I wanted to play a little game. So I want to see how many differences you can find between these two images. Okay, I appreciate that was quite difficult from the back and it's quite bright. So, could I have a show of hands if you found 1 or 2? Can you keep them up if you found 3 or 4? 5 or 6? 7? 8? No, okay, that's brilliant though. So there were 8 differences. I can't believe you could see that from there. It's fantastic. So if we just run through them very briefly. Again, some of these are really difficult to see. So there's a slight coloration on this image, so that wouldn't get picked up with Selenium. You've got a text change, which will get picked up. There's an image of I think it's a Windows emblem on a laptop, that's in an image. You've got text, padding, comma missing, a style, and then exclamation mark missing. So of all of those, from typical sort of Selenium UI tests, only 4 of these changes will get picked up, because 2 were style and 2 were images. And whilst that may not seem like a big deal, if you work with banks or companies like that where branding and colours and things like that matter, then it's a big deal. And the problem is, that was a short amount of time, but when you're up against it and you're releasing software in quick cycles, how do you know when to stop? So how can we start to look at the UI level, and a lot of the tasks that we manually do, how can we start to add more value and automate these? So what if we could say, I've got this base image that I've taken with my whatever WebDriver I want to use, and I just want to assert that every time that I view that web page in my check, then I can just compare the images and say, does this image look as I expect? So when it comes to visual testing, there's not quite as many options. These are just a few. And again, it does depend on what you want to do. So a lot of these are free. So Phantom CSS, Wrath, and Backstop.js are free. And they rely on you being able to write the tests in JavaScript. They're on GitHub, which is good as well if you want to sort of get hands-on and get some support from the community. Personally, I haven't used it myself, but I've heard good things about it. It's about $149 a month, and that's for 5 users. Ghost Inspector, again, I haven't used that, but I'm told it's pretty good. It's free up until a certain point. I think it's 100 test runs. And probably my favourite, so I don't work for these, but I always talk about them, is Applitools. So Applitools, unlike any other, there's two. So Applitools and Mabel, they use AI for visual checking. So the difference there is all the other frameworks, what they do is they'll do like a byte-for-byte comparison. But Applitools and Mabel, what they allow you to do is if you imagine you had 4 tweets, and you wanted to compare if these 4 tweets looked like these 4, but the content was the same, but in a different ordering, they can detect if it's still the same content, even though the order's different. And they'll also allow you to run your checks against a web application, and it will automatically detect, based on the number of times that it runs, what areas are dynamic, and it'll highlight them for you, and it'll automatically ignore them if you wish. So it's quite clever stuff. Applitools give you a free trial. I think it's quite high, something like 1,000 validations or something like that a month, and then you can pay for it if you want to. So when I was developing this, I was trying to get the company to use Applitools, but what we found is, so this link on the board, and I'll share it at the end, it was enough for what we wanted, so we just rolled our own. But if you find it's not enough and you get in lots of issues, there are lots of nice things out there. Applitools give you a nice GUI where you can draw over areas of interest, so you don't have to write code either, so it's quite a nice tool. But for us, when we were doing looking at visual testing, lots of these didn't work out of the box, and they contained lots of bloat. And when we're trying to get people on board with writing visual checks, we'd only just got them to write end-to-end UI tests. So it was quite difficult then to say, well, actually, can you do this as well? So it was a steep learning curve, and lots of these tools are quite new, so it was lacking support, so it was quite involved for people. And for us, it needed to work with the current automation framework, which was .NET and C#. Bear in mind we had all of these sort of helpers as well, which we were trying to leverage and just add or sort of piggyback the visual check-in on top of it. And again, costs. Whenever you try to introduce something new into a company, cost is always an issue. So we had to try and prove the value in these types of checks before we could try to justify getting a tool off the shelf. So these were a few of the issues. The main issues, probably, to be fair, was that it was the way that we developed the software. So we had things like generated IDs, and we weren't consistent in our approach across many products in our teams, and the teams didn't really work that well together. So lots of the problems in trying to get this integrated was because of the way we worked, unfortunately. So when you start looking at visual testing and you start taking screenshots, what we originally intended to do was to take a snapshot of the Google homepage in Chrome WebDriver, and then what we would do is we would use the same base image within Firefox, for example. But what you find is all these pink boxes down the side, this is where Firefox thought there were differences compared to the Chrome base image, even though there was no difference, but it's because different browsers render slightly differently. We wanted to try and improve how quick it could be. It's probably quite difficult to see from the back, but what I'm actually doing is declaring an image, Google PNG, giving it a URI, which is the page I'm going to test, and then just asserting, is there a difference between this URI and the image? So it'll go off, it'll launch a WebDriver window, go to the home page, take a screenshot, and then it'll compare it, and it'll hold that image in memory. So 4 seconds, it was able to tell that the image was as expected. So this was a check against a Chrome base image against a Chrome base image, basically. So I thought we'd play another game, try and keep everybody awake. So to try and show how much this could improve the way we worked, I wanted to show that even when we've got a lot going on, so we deal with, or we used to deal with lots of customers in different languages. So when you're trying to look at, for example, a web page with lots of different characters and things that aren't familiar, it can be quite difficult to spot the smallest of things. So these are the 2 base images that we gave the system. See if we can find this one. So we'll zoom in. So Wally is in the right-hand picture somewhere. zoom in a little more. Okay, so he's hiding up the top. So as you can appreciate, I know that's a bit of an over-exaggerated example. There's a lot more going on than you'd find, hopefully, in lots of these web applications. But when you've got a lot going on and you've got time pressures, it's really difficult to find the smallest, well, very small things in your applications. So the machine was 293 milliseconds, which is, really good. And what it'll actually do, when it finds the difference, because obviously Wally was in one picture, not the other, it'll output the difference image, and I'm not sure if you can see it, but there's like pink boxes around the image, so it actually outputs an image for you. So if you've got that as part of your continuous integration on like TeamCity or something, when it fails, it'll actually put the difference image as an artifact, and you can download it. Some of the other tools will actually, like Apply tools, will allow you to, if a test fails, perhaps sometimes you want it to fail because you know you've updated the base image, so you can actually accept the change as part of your CI pipeline. They'll update for you. So this isn't as advanced as that, but these are the sorts of options you can look at, because as you can imagine, if you're managing lots of base images, it can become quite a manual task in itself. So if we look at the old code, sorry, I'm not used to all the cold, sorry. So this was the old code that we had for the contact form. So when you start then looking at what we're actually getting from the visual check-in now, we're no longer having to check lots of different elements for text, which we're hard-coding into our tests. We can just say, well, we don't really care what the text is. This is how it should look. Does it still look the way that we expect? And we're getting lots more value as well. So not only are we checking, is the contact form text on the page, we're actually saying, is it in the right font size? Is it the right color? Is it the right position? So you're getting a lot more value out of your checks, and it's for a lot less investment as well. So a lot of these frameworks, what they'll do is, you don't have to, when you write your initial checks, you don't have to create all the base images. So when you write the test for the first time, it's going to fail, but it'll actually create the base image for you and say, use this one, this is what it currently looks like. So if you want then to use that base image, it will just work straight out of the box. I'm not sure if anybody here is familiar with Specflow. So Specflow is a .NET port of Cucumber. So what that allows you to do is, again, if you work as part of an agile team and you're writing acceptance tests, you can copy those across into scenarios. And then behind the scenarios, you get the back-end steps. So you can basically copy the comparison code into a step. And then you can basically reuse. It doesn't matter if you've got 50 pages. You pass in a variable of a URL and a base image. And it's the same code. So it doesn't matter how many pages. You're not writing hundreds of these for each different page. It's just reusing the same code. So when it comes to maintainability, it's really, really easy. Again, if you didn't want to write lots of scenarios, you can use I think it's called a scenario context, whereby you just have a table. So you wouldn't have hundreds of scenarios, you'd have one, and you'd have a table of data, say URL image, and it'll just cycle through them. So it's really nice for maintainability, and you're getting a lot of value out of these checks as well. You can identify. Okay. Yeah.
Like most
yeah.
pages are dynamic.
Yeah.
If you have to like test them a lot, then there's lots going on, then there's dynamic content.
Absolutely.
Like the contact form would just be like on the part of the page.
Yeah. So I'm going to cover that in a second. And if you've still got a question, please ask, if that's okay. So yeah, there's options. You can output the image just with the differences. Or so Apply Tools doesn't have this issue, but when you look at the byte for byte comparison, tolerances are an issue, so you have hardware differences. So this image is basically saying, I run the tests on my machine, I run them on another person's machine, and it thought there were differences, even though the images were the same. So it'll output an image with numbers to show you what the tolerance you should apply to allow the subtle differences. It can be pixel perfect, so you can get to a single dot, a single pixel on the screen. And if you use the same driver type, obviously if you're trying to cover lots of different different devices, you're going to have to take a base image for each of the different types of devices. But as long as you're using the same device and the same base images, there is no quality difference. Obviously if you start using different hardware and things, it can differ, and I'll cover that in a second. So base images, maintaining them has been quite a chore. We had to cover IE, Firefox and Chrome, and we've started to look at different types of devices like desktop, different size desktops for making sure the website was responsive. And when you start to take account for all of these different things that you want to check, all of a sudden your base images becomes quite a manual process, and the whole point is you're trying to automate things so it's less painful. So what we actually reverted back to was just checking in Chrome in the desktop, and we felt that was enough for us to give us value. Obviously it differs depending on the applications you're dealing with. Screenshots, so by default, it's a W3C standard, you only get what's in the viewport, but what we've done is we've got, we stitch together, we inject JavaScript so we can scroll through a page and take snapshots so we can get full pages. We can also as well, so for example, if you've got dynamic content, you can give it an ID or CSS selector, and you can get just to the box. It doesn't matter about all the noise around it. You can get straight to the element. And you can even get down to, well, it's just an ID or a class. You can get to individual buttons. So what we've used this for is where we've got banks and they've got their own branding. We just have checks for, are all the buttons styled in a certain way, or all the sidebars or the headings. So you can get down to that sort of level as well. So that can help with dynamic content. This really caught me out. So it seems really obvious now. When I first wrote this proof of concept, what I'd actually done was I'd maximised the window and then run the checks. So then when I went to the demonstration, we ran the checks, I'd had to remote into another machine, and the screen resolutions were different. So it seems a bit daft now, but the way to get around that is not to maximise the window. If you're taking screenshots, you just set a height and a width, so it doesn't matter the screen size. It's still the same size base images that it's going to then take. But it really caught me out, so it's worth sharing. Responsive design, so yeah, we set up profiles, and we would declare which profile we wanted to run for our tests, or many of them, and again taking base images for each size. But again, you have to be careful, because when you start to take all these different base images, it can become quite a chore then to try and manually go through them, to assert, are they correct? Hardware issues, so this is the biggest issue when you look at visual testing and why many people just don't bother with it. So, like I mentioned briefly, this is an image of where it found differences, or what it thought. And it's to do partly with anti-aliasing. So on my machine, it rendered slightly differently to on the colleagues, but to the human eye, it didn't look different at all. So this is where you can generate a tolerance image, and then you can say, well, the highest tolerance number is 21. So you can set that in the configuration, so it will allow for subtle differences like this. It's then not pixel perfect, but we've used it whereby we've checked an A, we've changed like an A to an E, and it's picked that up. So it can still be of value. Some of these things using like AI, they get around that totally, but this is just byte for byte comparison, so it's quite basic, just to give you an idea. Another thing you can do as well is you can run this in a Docker image, and you get the Docker image to always take the screenshots and do the comparisons, so you know that it's a known environment that's actually doing the comparisons, and that tries to get around the issue. Again, storage is an issue. If you're starting to look at supporting loads of documents, we were doing this locally, it builds up quickly. And if you think every time you run the checks, if they fail for each of the devices, you're going to get an output difference image as well. So quite quickly can grow and grow. So you've got to be mindful of that, and we were just doing this locally. Perhaps you could look at cloud storage, but it really depends on what's valuable to you. And again, not just doing everything because you can, automating all these different devices and screen sizes. Again, so dynamic content. Another thing we looked at to try and get around this was that sometimes you may have text or something that's shifting the page quite considerably. So how do you get around that? So what we did, we created a little bit of JavaScript which we inject into the WebDriver, and we find the element by an ID or class. We find its top and its left, and then we inject a div at the same top and left, height and width, and we blanket it, give it a Z index to throw it over the top. So, and then when we take the base image, we know that it doesn't matter what changes under that area, it's always going to be the same, elsewhere on the page. So that's one way you could try to look at it. It's not perfect. But again, when you think you've got that option, or you can get to the individual element level, it's still quite powerful. moving elements, so you may have CSS animations or videos. So again, you should really utilize the where you can inject the JavaScript into the WebDriver, so you can stop CSS3 animations and videos. Just a quick sort of Google on Stack Overflow or something like that will give you some JavaScript for that. And what the other sort of tools don't really talk about, and this was the most valuable thing for us, was you can actually do PDF comparisons. So when we were getting to the end of the journeys for our customers, sorry a second. Sorry, I picked up an itchy cough this morning. So when we were doing, what we were actually doing was, we'd get through the journey with the customer, so they'd log in, they'd agree to like a loan or something like that, and they'd agree to all of these things, and at the end they would then sign, and it would stamp a date in the document. But sometimes these documents were quite large, and then we had GDPR with all different versions of documents which we then had to update. And it was quite a manual process to check, like a 22-page document. It would take hours for somebody, especially in a different language they're not used to, trying to check. And it's very easy to miss things. So what we did, we basically used, there's lots of different third parties out there, but we used Aspos. I think there's another one that's free, PDF Soft. And what we did, we created a helper for that. So you could say, either give me all of the pages or a page I say, and convert it as an image, and then you run that image then through the image comparison. So quite quickly, you can check full PDF documents or Word documents by running it through the same visual testing, and that's really where we got a lot of our value. PDF dynamic content as well. So this wasn't really from our tool, but as I mentioned it anyway, you can stamp documents with the dates in this journey. So what we were doing, we were using regex to basically find the date, inject a known date over it, and then doing the visual comparison. And this was quite interesting as well. So another thing you can do with visual testing, if you design, so if you use D3 or something like that, and you start to create your own charts, what you can do is we created a JavaScript function, and we would basically modify the data set. So we had checks that would ensure that the data come into our the UI level was correct, but then we would call a JavaScript function to inject known data into our charts and do a visual comparison, just so we could check that the custom charts we were developing were actually rendering as expected. So we'd throw it random but known data at our charts. And lastly, this as well. So this is something I stumbled on quite recently. So what you can actually do is, if you care about accessibility, which I know you all do, what you can do is sometimes when you look at accessibility checking, or testing, sorry, lots of these tools, what they'll actually do is just check the markup, and they'll say you're missing some ARIA tags, or you're missing, this input doesn't have a corresponding label and things like that, or color contrasts. But you should be checking as well the sort of the tabability, the flow of your systems. So what you can do is there's a Chrome extension called Chrome Lens, and what that'll allow you to do is as you tab through, it will draw the red lines. So we've taken that one step further, and we've created our own JavaScript, which will actually, when we call the helper, it'll go to the page, inject the JavaScript and draw the red lines instantly, and then take a screenshot. So if somebody changes the flow of this application by changing, a tab index or something, we can see the flow of the application. So you can start to think about accessibility and other sort of opportunities then to try and write your tests. So it's really, really good. And again, just because you've seen this, hopefully it's whet your appetite and you want to find out more. There's a link here, which is very rough and ready C#.NET project. But if you really want to get sort of up and running in probably less than a minute, famous last words, you can go on NuGet and you can run this command. It will set up everything for you, pull in all the web drivers, it'll create lots of test classes for you, and all the examples I've shared will be instantly available, so you can just run them on your machine against Google and try them out. So again, just because you can do it, it may or may not work for you, but it's certainly something to look at if you find that you've got many UI checks which seem to be taking a long amount of time to implement, maintain, and to execute. So that's all I had today. Thank you very much. Yeah, if you have any questions, is that okay? Or sure.
So when using this in a real-world scenario and the test fails, how often do you find that this was useful and this actually pointed to a problem, and often you find that the problem is that the test is incorrect, base image is incorrect, and you made a change that doesn't actually, it isn't actually a problem.
Yeah, that's a good question. So initially, when we were trying to cover off lots of different devices and we had lots of base images, we found it's quite difficult. We were getting false positives, but we found when we started to target a particular browser and we just concentrated on the journeys that of more risk and add more value for us, then it became quite useful. So we just had Chrome desktop checks just for one journey, and it was useful in that respect. I think for it to be really sort of useful and powerful, I'd recommend going to something like Apply Tools, which is it improves the flow and how you get around the sort of false positives. This is very much a rough, ready sort of proof of concept, if you like, just to try and show there was some value to the business before moving on to something that cost. Thank you. Hello.
Hello. You mentioned you had a batch of tests that took like 4 hours.
Mm-hmm.
So what's your state? What's your state about that now when you're using this?
So I don't work for the company anymore. I'm hoping that they still have looked into this. So what we took was we had checks, if you like. So we had, if you imagine like PowerPoint, so you'd log in as a bank, and then a customer would log in with a generated code, and you would show them these screens. So we had checks check each individual slide and check all the text. Then we had one test, and at the end that would actually run through the happy path. So what we did was, if you imagine each test took a minute or two, we kept the happy path flow through the test, and then the ones where we were checking all the different text per slide, we replaced with visual testing, and it was probably more than half the time saved. But don't be deceived though with the speed in execution, because if you imagine you've got an application where you have to log in and you have to generate the code, and then the customer has to log in, you've still got all the startup time as well. So you're still going to have that, but if the real value, I think, is if you're checking lots of things on a slide, you're replacing that just with a simple check. And you get more value out of your checks as well, because you're not just checking text, you're getting colours and lots of different things. So it may or may not be faster, depending on your context. But for the journey that I try to replace with this visual testing, it almost halved the sort of speed. But that then wasn't moved into production with the other 50-odd suites, unfortunately. Yes, yeah. But when you run them in isolation and compared the two, it was quicker. Well, thank you very much. Thank you.